The dot product has some properties we want to look at. So we're going to let u be the vector with components u1, u2, and v be a vector with components v1, v2. Also, we're going to look at w as a vector, we also have vector, so our vectors are going to be u, v, and we're also going to look at w. And we're going to look at scalars. Right now I think we just need to look at scalar a. Well, what we see then is if we have u dot v, this is the same as v dot u. Because it doesn't matter which order we write them in, no matter what, we're going to multiply u1 v1 and then add that to u2 v2. We then see that if we were to scale vector u by 0, or do a dot product with u, this would be the same as just getting 0 for the dot product. Then if we were to take the magnitude of u squared, this is the same as doing u dot u. Next, if we were to do u dot v and scale by some scale factor a, this is the same as first scaling u by the scale factor and then taking that vector with dot v. And then lastly, we could do u plus v, so add the two vectors and then dot with w. That's the same as doing u dot w plus v dot w. Those procedures will give us the exact same answer. So make sure you have these 5 down, where in the examples u, v, and w are scalars, or sorry, not scalars, u, v, and w are vectors, and 0 and a are scalars. Let's look at an example. If we know that the dot product of a vector u with itself, so this is telling us that u times u is 8, we're going to determine the magnitude of u. Well, let's look back up at our properties here. Our third property tells us that the magnitude squared equals a vector dotted with itself. Thus, the magnitude of u equals u dot u, which equals 8. Magnitude of u equals 8. And that's it. Alright, let's look at another important theorem. This is actually a really important theorem. The dot product theorem. This tells us that if we let two non-zero vectors, u and v, be depicted so that their initial points coincide. Right, that means we have vector u pointing off in some direction, and then we have vector v, where both initial points are at the same location. Let theta be the smaller of the two angles formed by vectors u and v, so that this value of theta should be somewhere between 0 and pi, or somewhere between 0 and 180 degrees. So if I were to widen this up, here's theta. Theta is not this blue arc here, it's the green one. Alright, what I find then is that u dot v equals the magnitude of u times the magnitude of v times the cosine of theta. Or this means I could rearrange and solve to see that cosine of the theta equals u dot v all over the magnitude of u times the magnitude of v. This is a very important equation, and we're going to be using this in some examples in this section. So let's look at example 3. We're going to find the angle theta with the dot product theorem. So you're told that the angle between the vector u and the we want to find the angle between the vector u, which is -3, 1, and the vector v, which is 2, 5. Take a moment, try to do this on your own first using our dot product theorem. When you're ready, resume the video and you can check your solution.